friends. Thanks for, on this last day, coming to our talk, an overview of Cloud IoT Core. I'm Gabe Weiss.
And I'm Gus Class.
We're engineers working on Google's cloud platform, specializing in IoT. We're going to bring Gus back on a little bit, but first, I want to have a little chat with you guys. First thing I need to know, who are you? Quick survey time. Who out there are engineers, are the people that do the work, developers? Oh, nice. OK, most of you. Good. Do we have any biz dev, managers, C-levels, kind of decision makers? All right, got a couple here. Good. Don't worry, I'm not going to actually call on any of you. That's what we call that theater of cruelty. I won't do that to you. Do we have any data scientists in the crowd? Ah, nice. Good, good, good. All right. Just to make sure we're all on the same page, who knows what IoT is? OK, most of you. What about IoT Core? All right. Good. Just to make me feel better, do you all know what Google Cloud Platform is? Even if you don't, raise your hand. Just make me feel good. OK, so for those that haven't heard of it yet, I saw a couple of hands didn't go up. IoT, it's the Internet of Things. I actually voted for 5TI, things that talk to the Internet. I thought it would have been a little more indicative of what it is. So what is IoT? A computer. Your computer connected to Wi-Fi, IoT device. Your smartphone, IoT device. Smart meters connected to your house, electricity, gas, all of those, IoT devices. Raspberry Pis, microcontrollers. We'll get to all of these. All of these are IoT devices. In 2015, Business Insider, along with Gartner, did a study that said by 2020, 30 billion connected devices, 30 billion IoT devices. That's the phones and the computers, you can see, are a tiny slice of what we're talking about here. So why aren't we there yet? Why isn't my world connected and smart? Well, these things take time. They take money. So to really understand what the holdup is, I want to do a little brief introduction to the world of electronics. Does anyone know, if I say the word constrained device, does anyone know what that is? A constrained device? A couple people are nodding. OK. A constrained device is a tiny computer. It's got its memory, its processor, its analog to digital signal conversion, all in a single chip. That's a constrained device. So because everything's on that single chip, it's called constrained because its memory, its processing, its storage are all severely limited. This is the class of computer we're talking about when we talk about 30 billion connected devices. Who remembers floppy disks? I'm not talking about, hold on. I'm not talking about the 3.5-inch firm ones, 5 1/4 inch, the really floppy ones. All right. Now, I know some of us are old enough that we remember there were bigger ones, right? They're like the dinner-sized plate ones. Those aren't the ones I'm talking about. The 5 1/4-inch floppies, those things held 360K of storage. These microcontrollers hold less than that on average. If we remember those floppy disks, a single program came on many disks. So to load an application, we had to switch those things in and out to load your program into RAM. We don't have that luxury with microcontrollers. We can't just swap them in and out to load an application. That's why we need something, a more powerful computer, or Cloud IoT Core, to expand the capabilities of the device. So since I keep bringing it up, I want to make sure we're all on the same page with IoT Core. What is IoT Core? It's a 100% managed service. This means that you don't have to stand up anything. You don't have to put a service up in a VM. We handle all of that for you in Google. There's no need for auto-scaling, redundancy, scaling. All of that is done by the cloud for you. IoT Core provides a global endpoint. No matter where your devices are in the world, it's the same endpoint. So latency is to your nearest data center and back, and that's it. IoT Core has two main pieces. It's a communication broker, and it's a device management. For IoT Core, the organization of it is you have IoT Core. Inside, you create registries. Registries are buckets for your devices, so you can create some logical organization to them, and then the devices yourselves. The messages from your devices will, using either HTTPS or the MQTT protocol, shuttle your device's data up into the cloud. And then IoT Core brokers, that's the communication piece, your messages from IoT Core into Cloud PubSub, and we'll talk about PubSub later. PubSubs are event stream manager. And from there, it's the gateway. IoT Core gives you access to the rest of Google Cloud's platform. So to wrap your head around where we are now and why it's really getting excited, I want to go back to our little history lesson and talk about how electronics evolved. In the before times, your household stuff, like your blender, your microwave, your washing machine, all of these were made up of electronic components like capacitors, diodes, resistors, things that would respond to electric signal strength alone. The more powerful the signal, the more it would happen in the electrical components. So your microwave, for example, how it works. The magnetron inside your microwave, you increase signal strength to it, your food gets hotter. Decrease signal strength to it, and it reduces the temperature. That's how basic electronics work. Because of the physical relationship of these components to each other, as the electrical signal come in, each component would actuate or not actuate the next pieces in. It's like a Rube Goldberg machine. And because of the tight physical relationship to it, change was very difficult. If you wanted to change functionality of your electrical circuit, you had to make physical changes to it. You had to change your BOM, your bill of materials, so there would be cost associated with it. The minute you add something to an electrical circuit, your resistance goes haywire. You might have to change the whole layout of your circuit. If you wanted to mass produce your circuits, this is a problem. Once you've created your tooling for your manufacturing line on your circuit, mass producing the same template's nice and easy. If you've introduced change, now you have to retool everything to recreate your circuits. So it was very expensive to make any kind of change. Some of these kinds of circuits, we call them the analog circuits, still exist today. But modern electronics, and why this is all exciting, are a little bit different. Modern electronics are still composed of sensors, components, actuators, all of these things that still work with electrical signals. But instead of the way that we used to do it, where signal strength was what changed things, now we have things called digital protocols. Electrical signal will go on and off very rapidly in a predefined pattern, a digital protocol that is understood by another piece in the circuit. This means that we can center our electronics around this constrained device, this microcontroller, which is very good at reading signals, both analog and digital, and speaking in this digital protocol. The chip itself can now create functional change in your circuit without having to physically change anything around it. It's important because they're inexpensive. Until relatively recently, these microcontrollers were pretty expensive. But now, mass market, I can go out and buy a microcontroller with Wi-Fi and Bluetooth for less than $5. So adding these complex circuits and creating these complex circuits is now very inexpensive. The trade-off, of course, is that microcontrollers are still relatively constrained. They don't have a lot of memory. They don't have a lot of storage. So they need something else to help them achieve the capabilities that they're not able to accomplish on their own. So hopefully this gives you kind of a backdrop for why we're at this tipping point with electronics, where cost and complexity have arrived where we can do things at scale. Being able to create these cheap, complex circuits with the microcontrollers allows us to think about creating those cheap or inexpensive, complex smart devices that are going to connect our world. So take a step and let's talk about smart devices. What is a smart device? At the simplest, a smart device is something that can complete an objective, that can do a task without human intervention. I don't need to do anything for it. Modern electronics and the availability of these microcontrollers makes intelligent control of these devices economically feasible. And you might notice, I'm really harping on economically feasible and inexpensive, and I am. If there's just one takeaway that I want you to walk away from this talk with, it's that what a few years ago might not have been possible because of cost and complexity is easily achievable now. We have the tools now to create these ecosystems of smart devices. So smart devices, so we can understand them, there's three basic approaches to a smart device. I'm holding up 3 fingers. First, there's 100% on device. Everything is contained and done within your single device, something like Google Home, where I can use my voice as the input to a device. It uses speech to text to convert to text. It uses natural language processing to analyze what I really asked for, because maybe I didn't ask for the right thing, and run some kind of task on device, and it can accomplish it, all without me having to do anything else. I have a spoken word, and something happens. It might use the internet to call out to do something else, but that's part of the task it's already accomplishing. The second, there's edge or border routing. Sometimes we call it as the radio protocol approach. For example, Nest has released something called OpenThread. OpenThread allows your device to call out to another nearby device to take advantage of its capabilities. So say you've got a device that can do everything except internet. But whatever the task is, it needs to be able to call out to the internet. Well, with OpenThread, it can reach out to another device that's nearby and connected and borrow its internet connection in order to accomplish its task. It's still doing some of the work on board, but it's using these other devices to finish off what it needs to be done. And lastly, a device can delegate all of its control to something else. A lot of the times these microcontrollers do that. So they will become a very dumb but very fast gatherer of information, gatherer of data, and then hand off all of that I/O to something else, a computer nearby, the cloud, something else. Fermata, made famous by Arduino, that's the perfect example of what this is. Over a serial wire, you can delegate all of your control, all of the information that you've gathered on one device to a computer, to something else nearby. So what if I told you that the computer that we're connecting to, that is doing all of this power for us, didn't have to be anywhere near the devices? And that's where we're back. That's where we're back to IoT Core. This is how you can start to think about that. Like the concept of Fermata, IoT Core connects your device to the cloud. It expands the capabilities of this little device and all of its data it's collecting to the power of the cloud. It gives your device these new capabilities without adding any complexity. You don't need more local hardware. You don't need anything local. All you need to be able to do is talk to the cloud. So all of this so far, that our history in electronics, our talking about smart devices, is to hammer this point home where we're in a world where creating devices that talk to the internet, it's not only easy, it's inexpensive. And here's the inexpensive again. We can all do it. So I've touched on why the cloud is integral to IoT. But just in case you aren't convinced yet, I want to show you a couple of things to make sure that you understand. Let's take a look at this graph. This graph is all of the oil and gas fields in the Gulf of Mexico. There's a little over 1,300 of them. Each of these gas fields could have potentially thousands of sensors all streaming data. To keep our math simple, let's say it's just 1,000. From there, let's say that each of these sensors is only streaming 100 bytes a second. It's nothing, 100 bytes a second. Even if that's true, that's 137 megabytes a second. It's just over 8 gigabytes a minute. It's 11.5 terabytes a day. You could manage that data if you want. I'm just saying, there's a reason the cloud was created. The cloud offloads all of the infrastructure, all of the overhead of managing this big data. You don't have to worry about backups. You don't have to worry about IT people to run your machines and make sure you've got uptime. The cloud handles all of this. The other point I want to talk about is security. Some of you may have heard about it. A couple years ago, there was a thing called the Mirai botnet attack. This is where a bunch of unsecured devices, mostly routers and stuff like that, were hijacked and used to attack the domain name services of the internet, DYN. Took down huge swaths of the internet for a pretty good amount of time in the internet scheme. Also, a temperature sensor in a fish tank. Last year, this happened. A temperature sensor in a fish tank in a casino was compromised. The hacker was able to, through this temperature sensor, pull out all of the personal information of the casino's high rollers, all through a temperature sensor that didn't happen to be secured. So security is massively important. If you're doing IoT, you need to think about security. IoT Core registers all of your devices with an SSL key pair and does all your encrypted communication through TLS 1.2 or later to ensure that all of your devices are secure when they're talking to the cloud. So we understand now, hopefully, why IoT Core is awesome, but what else? IoT Core is this gateway into the Google Cloud Platform. What does the Cloud Platform have for you for IoT? This is a small sampling of what Google Cloud Platform offers. If you want a really good time, go to cloud.google.com/products and start scrolling. And just keep scrolling and keep scrolling. It's really impressive. There's enough products on there that even we don't know what all the products really do. They're all specialized. There's a ton of products that will fit pretty much any need that you want. But back to our sample. So first, we've got our devices bringing their data up into GCP. As I've talked about before, these payloads, the messages, end up brokered as events into Cloud PubSub, our our event stream manager. From there, once it's in PubSub, we have some products that can respond to our incoming messages. We've got Cloud Functions. Cloud Functions are serverless functions that just exist in the serverless space that you can call either with an endpoint, like you're calling a URL, or they can respond to events within GCP. In our case, the PubSub message coming in will trigger a Cloud Function to run on it. The other product we've got on here is called Cloud Dataflow. Dataflow is our managed service to handle transforming incoming streams. It's managed. So again, like Cloud IoT Core, it will scale without you having to do anything. However much data it's processing, it will scale to handle it. It can be used to do things like filter incoming data if there's only some data you want to make it into your final storage. Or it can massage the data into a specific format if you need it to be processed in a specific way. It also acts as a pipeline for your data. Cloud PubSub is temporary. Messages will stay there for 7 days. If you don't do something with them, they go away. You don't want your data to go away. So a product like Dataflow can shuttle your data into the other products, which brings us to our storage and analytics section. There's way more than are shown here. These three are just a very small sampling of what we've got. First, we have Bigtable. Bigtable is our NoSQL storage, our NoSQL database option. Again, managed service. It will scale with however much data you put in it. Bigquery is our enterprise-level data warehousing. It allows you to query your big data, petabytes of data, with simple SQL statements. That means your data analysts and your data scientists don't have to learn a new system. They can just use SQL to find insights within your data. They can spend their time analyzing data, not learning a new system. And finally, we've got machine learning. TensorFlow is the open source software that allows you to train your models and run inference against your models. Cloud Machine Learning Engine is hosted TensorFlow. It allows you to harness all of the power of Google's backbone to train and run inference on your models faster and more efficiently. Finally, we have tools that can visualize your data. We've got a couple of options here. We've got Cloud Data Lab. It's built on Jupyter, so you can build notebooks to visualize the data however you want. And we've got an out-of-the-box solution, Data Studio, which lets you look at time slices of data in charts and graphs, however you want to visualize it. So for IoT, with all of these together, you can do things like perform device management and monitor your health across fleets of devices. You can warehouse and analyze truly absurd amount of data. And lastly, you can perform things like predictive maintenance in manufacturing or utilities to see when your stuff is going to break using tools like machine learning. Cloud IoT Core provides that gateway. It provides the device management and connectivity for all of your devices into the rest of Google Cloud Platform. It's been only a year. Last year at I/O is when we announced Cloud IoT Core. So I want to take a sec just to highlight what we've done since then. What are the improvements we've made? First, when we announced that beta a year ago, it could only talk MQTT. If you didn't have a device that could do MQTT, you're out of luck. We've added HTTPS since then. So now a broader range of devices can connect to IoT Core and have their data managed. A year ago when we launched, each registry, remember those buckets of devices, mapped one-to-one to PubSub. So any device data that was coming into your registry would only go into a single bucket of PubSub. We've now added the ability to map multiple PubSub topics to a single registry. So you can shard your data that way. You can organize your data into multiple PubSub topics. We've added Stackdriver logging so that you can monitor your health through Stackdriver, which is it's a logging and monitoring tool that we've got. I forgot to mention it before. And brand new, and I don't think anyone's actually announced this yet, so I'm kind of excited I get to announce something. Android Things. I'm sure you've all heard a lot about Android Things across this conference. Android Things has created a plugin that they're releasing next week that will allow you to easily connect your Android Things devices to IoT Core. So all of those sessions that you went to about Android Things and all of the cool stuff you can create using it, now let that kind of percolate in the back of your mind. What more can you do with it? If it's connected to the cloud, what else can you do? What global reach can you accomplish with Android Things now that it can connect to Cloud IoT Core? So now that I've talked your ear off, I'm going to bring Gus back up, and he's going to show you in practice some of the stuff that I've been talking about.
Thanks, Gabe. Let's have a round of applause for Gabe and his wonderful blue hair. Look at this guy. Yeah, I don't know how I'm going to follow that. Just kidding. Actually, I'll be the yin to his yang, and I'll show you the things that he's been talking about. So this is actually the third time that I've shown kind of the nuts and bolts of how Cloud IoT Core works, and kind of this is I/O right now. And I remember a year ago, the Cloud IoT Core team came in front of you all and demonstrated the product for the first time. And when they did it, I have no idea how they were able to get such a robust and beautiful demo at that point in time, because there was a lot of pieces that the experience was a cliff. You know, the first time that I showed this demo that I'm just about to do, it blew up in my face, and that was because that was for a couple of reasons. One of them was we didn't have the cloud console features for IoT Core, so there was no visual way of adding devices and creating registries. And there also was no command line utilities for managing IoT Core. And so I had to write a sample that would make API calls with the device ID, the registry ID, the project ID, all of these values that are really easy to fat finger. So when we went to general availability, the Google Cloud Sdk, or G Cloud, for those who don't know, Google Cloud ships a command line utility that's written in Python, I believe. And it allows you to do all the things that you can do in cloud programmatically from the command line. And it actually works. It works really well from cloud resources. And if you go and do the code lab, I actually have you do a lot of cloud resource management using the G Cloud SDK. And so today I'm going to show you how to do the nuts and bolts of Cloud IoT Core just using the Cloud SDK as opposed to using the console or the command line or some API calls that I've hacked together in some sort of sample app. So I'll just unlock my machine, and we'll switch to computer. All right, can everyone see that? Good? Bigger, smaller? Good? OK. OK, awesome. All right, so if you remember, the entry point into Cloud IoT Core is Google Cloud PubSub. And so before we can receive messages and transmit, and before we can transmit messages and then process those messages from PubSub, we have to create a Google Cloud PubSub topic. So I'm going to create a Google Cloud PubSub topic. I'm super nervous, so I type really bad. OK. IO2013 top. OK, so I just typed in G Cloud PubSub topics create IO 2018 top for topic. And so now I do G Cloud PubSub subscriptions. So the subscriptions will, of course, my sub, and I forget the help. All right. So when you create the subscription, you have to associate that subscription with a topic. And then I have to add create. And if you see me struggling up here and know how to fix what I'm doing, don't hesitate to yell out something. All right. All right, here we go. Dash dash topic. All right, so now I have created a Google Cloud PubSub subscription that is associated with the Google Cloud PubSub topic. So now whenever I publish messages into that topic, then they get queued up in the subscription. And I can pull those messages from the subscription. So now I'm going to create a Google Cloud IoT Core registry. And I'm not the best typer and talker. And so associated with this registry is going to be an event notification configuration. And so what that just means is when messages are sent, telemetry messages, which could be something like sensor data from a device, when those messages come in, then this is the topic where those notifications can go to. And so you can also set this so that you can have event notifications going to other types of things, and in the future may offer other ways of connecting with cloud. So now I've created a registry, and the registry will contain devices that represent the identity of your smart devices or IoT internet connected devices. And so now I'm ready to add a device, and so the device connects using an asynchronous encrypted credential. So you give us your public key. And then you encrypt your data with your private key when you authorize, and you get a JSON web token. And so what this is going to do is invoke a couple of, I can never type those OpenSSL commands correctly. So really what all this is doing is just calling this OpenSSL command, which will generate a public-private key pair with JOT-compatible algorithms. And so now that I have my device keys, I can register a new device. And I'm going to call it E2E because that's the device that I recommend using for the end-to-end example. And if you want to follow on your own through a step-by-step example, you can find this in the documentation at cloud.google.com/IoT. And so when I create this device, I'm going to use the EC key that was created with OpenSSL, and then I give it the ES256 string representing the type because that is just the signing type that's correctly named for JWT. And after this comes back, then we're ready to connect to Google Cloud IoT Core. And so this is going to use, for this example, I'm just going to use the HTTP example, which is the most basic way of connecting to Google Cloud IoT Core. So this is just a Python sample. And so there's the project ID, that's the cloud resource associated with the device registry and the pub subtopic and so forth. And then the registry ID, which is the container for these devices, and the device ID and everything else that you saw me put in the previous message. And now Docker is going to ask me to update. Okay, I'll do that later. Yeah, OK, so all right, so here's the JOT that is calculated from the device. And because it's a brand new device, you'll see that its configuration is empty. And it's also yeah, that's nice. Nice stack trace. But here's the configuration for the device, and you can see that I've published a couple of telemetry messages that are events representing something that this device is transmitting to the cloud. And so now if I use gcloud again, pub sub, and I can do subscriptions poll. All right, I'm going to forget the name again. Description is Iot 2018 sub. And when I do this, I should see the messages, I should see those telemetry messages that were transmitted by the virtual device to the cloud. And this is always the scary part. There it is. So sorry for how this looks kind of funky in here, but you can see you can see attributes, which is like metadata for the device that connected, the time that and anything else that you want to push into your topic inside of this data field. All right, so if you've seen any of the talks before on Cloud IoT Core, you see me do this a lot of different ways. It's kind of boring. But these devices are really, but this is it. You've seen the entire capabilities of the cloud. Once those messages are in PubSub, then you can process those with all the cloud resources that Google provides. And so this could mean processing image data and then returning labels or reacting to some sort of condition inside of that image. Or this could mean warehousing massive fan-in of data and then being able to do analytics in real time with it. And so that's fun. But we're going to do something a little bit different today. And I want to show you this working on hardware. And so I have brought with me an Arduino device. And this has sort of been a 20% project of mine. It's an experimental library. And for those who don't know, Arduino is a physical computing platform that's very popular in education and with makers. And it allows you to do things like blink lights, actuate actuate electronic things, which kind of harks back to what Gabe was speaking about with modern electronics. So modern electronics can easily be controlled and actuated from Arduino devices. And so I'm going to do something, so the virtual devices are really good for things like load testing and estimating and like learning about the product. And then our experimental library with Arduino, which I cannot recommend that you go to production yet. As it says on my GitHub account, look out, it's my code. And it's also Alvaro's. So thank you, Alvaro, for all your contributions. And anyone who's interested in contributing to our Arduino project is welcome to. And so now I'm going to go from that virtual device, which is something that is useful for loading, to a physical, real-world device that we can then use for prototyping and other things to get an idea about like when you have your actual device built on one of the more robust solutions that our partners offer. But so in order to work with Arduino, you can just install the library using the library manager. And then after that library is installed, inside of the examples will appear Google Cloud IoT Core JOT. And inside of here, each of these there is a sketch. An Arduino sketch is just a way of specifying a source file, and then it's what is open inside of the IDE. And so inside of this sketch is this header file ciotc config, and then inside of here are all of your configuration that we just did in the virtual device, except as specified with this physical device. And I'm just going to connect to a Wi-Fi. And is everything else? And this is the same configuration that I just used from before. Sorry. Oh. This, yes. That, sorry. Oh, the project ID. Oh, yes, yes. So the project ID is, thank you. Thank you, yes. This could have saved you a lot of frustration in a minute. But yeah, so the project ID is the cloud resource that's associated with your, with all the things that you've created atop it. And then then I'm going to do a transform on the private key, which I'm going to use as for creating the connection credential. And this is an open SSL command that I can never remember. But maybe yeah, there it is. OK. So now I've taken that private key, and then I've turned it into this string that looks a lot like this string. And then I'm just going to replace this string with that string. And very soon. Now, when I click the run, oh, thank you. We're doing a good job, guys. OK. And I make sure I have the right board, the right port. OK. And this is, we recently, I added this support for the Genuino boards. These are kind of like the Arduino style boards. They have a feel to them that's kind of nice. Anyways, so now that I have, now this device has connected. Let's see. Let me look at my logs here. Oh, no. Something is wrong. Let's see. Oh, the private key is wrong. Oh, did I do the public one? Thank you. You're the best. And this should be EC. Let's try this again. Place it. Oh, I need to save the sketch. Sorry. We'll try this again. I'm missing, sorry, say that again? Oh yeah, actually this is so Arduino strings do support this. So this is working as expected. Let's see here though. Sometimes the time server doesn't return the right time, and that can get me. Oops. And so if this, there we go. OK, so now it's working. Yeah, so this is an experimental library, everybody. And I'm, yeah, so heed my advice. Yes. Yes. And that's why you shouldn't use it in production yet. But maybe someday. So now, in this sample, like if the configuration message is set to something other than the value 1, only one light will be on the board. And then if I set the configuration message to 1, so the configuration for this device is set to 1 instead of 0 or hello, then 2 lights on the board should turn on. And let's see. We'll set it to 1. And then everybody watch on that screen. It's the light that comes on is on the left side of the board, I think. And so we just updated the device configuration, and then through my blazing fast internet connection, there it is. Yeah. All right. OK. And so this is nice. Devices are fun. And being able to prototype stuff with Arduino is fantastic, actually, because you're able to do stuff really quickly, and you're able to, in just a short period of time and inexpensively, get to have an understanding of whether or not something will actually work.
So the mic, ooh, my mic is on. Do I need to get close to you? Can we use this mic? Oh, it's attached. That's going to end poorly. Do I just need to get really close to you, Gus?
All right.
Here.
I will speak to Gabe, and Gabe will speak to you.
It's going to be a great game of telephone.
OK. So 3 weeks ago.
So 3 weeks ago, Gus
Needed to do a demo.
needed to do a demo to this conference. Yeah.
And I had nothing.
He had nothing. So he went to the sound guy who's getting him a new battery pack.
And I had lights, actually.
He had some lights. He had some project he was working with LEDs.
And oh, we're back. Okay. Yeah. Let's hear from the sound guy. All right. And so yeah, I had lights, and I thought you all would be much more excited if I showed you robots. And so I had this toy. It's a toy like this. And I want to show you it under here. So it's this toy. And this little toy has, remember Gabe was talking about digital systems, on and offs. Well, this toy has something, I saw this on this toy. It's got an infrared receiver. And it has this little remote associated with it, which I have smudged off anything that will hint at what it actually is. But this little toy responds to a blinking light on here. And I just showed you a blinking light. So what if instead of that little light, these signals, these configuration messages that are transmitted to the devices are then instead interpreted into the motion commands for this little toy? And I thought that was cool. And so I started prototyping, and on boards very similar to that other one I showed you, and I came up with this. My friend added some flair and some character to this little guy. And so what happens is when the device comes online, it should wiggle a little bit. And that way I will know it's connected to the Wi-Fi. So there's a little blinking light that indicates the various stages of the boot. And I'm going to start a Flask app. All right, there it is. So when it just nodded its little head there, what was going on was it's now connected to Wi-Fi. Oh.
You do your thing.
OK, it's now connected to Wi-Fi, and this is not the device. And now I can go into my device registry here again, and I can send configuration messages and then control this. And what's interesting is that no longer is it something that's like a device that's locally here. This device could be anywhere, and it doesn't really. And there could be millions of these devices, and you can do things like coordinate across those devices. Anyways, so let's send a configuration message to the device that will cause the device to turn its head. And so when the device responds to the command, it should just nudge a little bit there. There it is. OK. And so you'll also notice that on the front of this device, I have added a sonar sensor. And that sonar sensor will pretty accurately measure distance up to about 30 meters away. And so I wanted to do something that shows getting data from your devices, putting that data into the cloud, and then processing that data. So very similar to what we do in the code lab. And so I created that little Flask app. And then this little Flask app has this UI that only a developer could love. But when I click that button, it sends a configuration message to this device. If I'm lucky, if it's not cached, let's see. And that configuration message will trigger this device to start moving in this sort of sonar pattern. And I mean, these are toys, so I mean, it's not going to turn exactly the same amount of degrees every time, but it's close enough that we can kind of get a general idea for the surroundings around this robot. And then on the blazing fast internet to my computer, it should render. Oh, that's nice. OK. Still good, still good. All right. And so then we render. It's all right, you can clap. So then we render a graph kind of the surroundings of this device. And so adding the internet capabilities to this toy was as easy as just adding a hat on top of it. And also, because of the low requirements for the hardware for Cloud IoT Core, I'm able to build these hats at a cost of maybe just $5. And so you can imagine in your factory or in your store or in your office or wherever you have these modern electronic systems that you can communicate with internet-connected devices, then you can add internet capabilities to those devices. And because they're so inexpensive, we actually no longer have to show my laptop. It's actually possible to produce a large number of these devices in a relatively short period of time, and then kind of have some fun with them. So sometime after this conference, I'm going to try to open source this software. So if you all want to make your own little internet-connected toys and kind of get an idea for how these kinds of things work, you can check it out. And for now, I'm going to do the thing that everyone wants me to do whenever I show them the robots, and that is make them move as a swarm army. OK. And it's at times like this that I really appreciate how little data the Cloud IoT Core product sips, because I'm totally not using my phone for connecting these devices.
Totally is.
Yeah. All right.
We should have a bunch of them online.
There we go. OK. And it's just about time for them to march. Oops. All right. And we'll go back to. And thank you, Gabe, for wrangling all these robots. All right, let's send some. Uh-oh. Look out. Go, robots, go.
It's the Wi-Fi.
It's probably the Wi-Fi. But, I mean.
They're blinking really pretty, though.
They are blinking really pretty. I feel pretty good about that. There they go. Yeah. So there it is. Thank you.
We have a jumper.
Uh-oh, uh-oh. All right. All right, they've already become sentient. This one's trying to break free. All right. All right. Yeah. Yes.
Okay.
I also wanted to do this just to make Gabe have to dance around on stage. All right. So let's go back to the slides, and we'll just wrap up. OK. So going back to other approaches to adding smart and intelligent capabilities to your devices, we would be, I want to again say, like there's other ways of doing this than just complete delegation to the cloud. You can use edge border routing to extend the capabilities of nearby devices to other devices. You can use on-device smarts with things like Android things. So if you have all the capabilities without the cloud, or some capabilities shared with the cloud, Android things is a really great way to do this. And also, we have stack, as Gabe mentioned at the very beginning, we have stack driver logging. And stack driver logging, for some people, can get them a lot of information about things like security audits and and that combined with the metadata of devices may be enough for a lot of what people's IoT needs are. And because we went a little bit over, I'll try to wrap up quickly, and I'll let Gabe close this out.
So we want to hear from you, how you thought about this talk. So please go here and enter in our talk, the Cloud IoT Overview. Thank you for coming. If you want to.